Good morning, ladies and gentlemen. Today we're going through and we're learning about potential and kinetic energy and how they can transfer back and forth. Right here I have Peyton Manning. Peyton Manning is about to play a football game, so the night before he eats a chicken parm. He used to sing, "Chicken parm, you taste so good." After he eats his chicken parm, his body is going to convert this into potential energy. The potential energy is going to be able to be used later when he's throwing passes. When he throws the ball and he's throwing and moving his arm, he will have kinetic. Over here, we have Sally the skater who skates, and we're going to say that she has, at this point, movement energy, so that's kinetic. She has some height that she can fall, that's potential. Her wheels are heating up, that's thermal. And we have this whole line, this total line right here. Okay, so what did we increase about the marble from our lab? If I go through and I look at this graph, it shows that I'm changing the mass. We remember from kinetic energy, if I increase the mass, the amount of kinetic energy is going to go up. On this one, we go through, we are changing something else. What we're changing is the speed. Well, how did we change the speed? We're changing the speed. Pooh Bear has a question. Where does the speed come from? We know that if we have more energy, we're going to have more KE. We've understood this, we've graphed this, but think. Where does the speed come from so that we can launch the cup further? Well, the speed in a roller coaster comes because of the height. As the height goes up, the potential energy goes up. As the potential energy goes up at the bottom, we're going to have kinetic energy. So as we increase the height, eventually we're going to be able to increase the speed. I want to say that a couple times. The height of the roller coaster is going to turn into speed. And that happens because potential energy and kinetic energy can transform. Up here at the start, we are going to convert potential into kinetic. Peyton Manning is converting chemical potential energy into kinetic. And converting potential to kinetic happens so often. Energy is energy, but it can take many forms. I made the point on this slide that if we take a look at the total amount of energy, it's going to add up to be the same. You learned in seventh grade science about forces. They go through and they teach you about the sum of the forces. Sum means add them all together. Well, here in eighth grade, we're doing similar things. Instead of saying sum of the forces, we're going to say the sum of the energies. If we add up all of these different lines, they're going to add up to be the total amount. And this total amount of energy never changes. We'll talk about that later in the year. But I want you to remember energy can't be created or destroyed. We're moving on. Right here, we've got Sally. She's up at the top. She has potential energy. I want you to notice that the blue line equals the total because all of her energy is potential. Down here, when Sally's at the bottom, all of her energy is kinetic. This line has not changed size. It's the same size here. It's the same size here. Now, we're going to go through and we're going to compare the speeds. We do have differences in energy. We have different types. It's kind of like if I take $100 and I convert it into pesos, or I convert it into euros, or I convert it into yen. I can go through and I can convert my money into different types of money. We can do the same thing with energy, and we'll talk more about that later on in the year. For right now, I want us to remember that because energy can't be created or destroyed, the total amount of energy is always going to be the same. What's different right here is Sally is going very slow at the top. When she goes down to the bottom, she's converting all of her potential energy into kinetic energy. And when she has kinetic energy, her speed goes up. This should be true. This should make sense because we've talked about converting our height into speed at the end. Well, that's all that Sally's doing. She's converting her height into her speed at the end. Finally, energy is never going to be lost. We've talked about that. The third type of energy that I want to introduce to this is going to be heat energy. Quick, right now, I want you guys to go through and rub your hands together. If I rub my hands together, I feel heat. Well, what I'm actually doing is I'm taking the kinetic energy of my hands, my moving hands, and when I apply them, I'm letting the friction turn kinetic energy into heat. And we're going to remember that the total amount of energy stays the same. So even though Sally is slowing down, she's not really losing energy. She's just converting her energy into heat. Takeaways: energy is going to transfer forms. If energy is stored, it's called potential. If energy is used, it's going to be, if energy is being used to move things, that's kinetic. Just because something slows down doesn't mean that it loses energy. And if energy slows down, it will convert kinetic into heat. You guys are amazing. Have a great day.